We are going to look at simple conditional statements. We look at compound conditional statements. We look at simple if statements and nested if statements. Basically, these should be able to give you everything you need to understand about if statements. At the end of the session, a video from this session will be uploaded to my YouTube channel, and this notebook itself can be accessed from my GitHub repository. Okay, now let's look at simple conditional statements. What are simple conditional statements? Okay, as the name implies, conditional statements, what they basically do is they return true or false. Okay, so if the statement you are proposing basically is true, then the answer you get is true. If what you're proposing is false, then you get false. Okay, there are 8 key operators you would normally use when writing conditional statements. Okay, basically, this is equal to, as you can see, it looks like what you normally refer to as equal to, but only you have 2 equal to signs. Then this is not equal to, well, all of this. So like equal to returns true if 2 variables are equal, okay, and false otherwise, or 2 variables or 2 statements basically. And this here is not equal to. Okay, so this, I'm sure you all know what this means. Less than, this is less than or equal to. This is greater than, this is greater than or equal to. And this is in. Okay, so you use this to test basically if something is a member, okay, of a set. So let's say you're looking at a set of cities in Sierra Leone, okay, and you want to know if Kenema is a city in Sierra Leone. So if you have a variable that represents the set of cities in Sierra Leone, and Kenema is another variable, and you want to know if Kenema is a city in Sierra Leone, so all you say is Kenema in that set, okay, and you should be able to get true if Kenema is indeed a city in Sierra Leone, or false if it's not. Okay, so if you were to take Abuja for example, then you get false. Okay, as you will see later. And then not in, as the name implies, is just the opposite of in. Okay, and what this returns is, it returns true if it's not in that set, okay, and false if it's in the set. So it's just a complement of in. Okay, so now let's look at a few examples. Okay, so now let's look at this first example. This first example is basically trying to test okay, so this is like a statement. Okay, this I'll say is like a statement or a hypothesis. Okay, and your hypothesis here is 2 is equal to 2. Okay, so if it's true, then what you get here, status here, should be true. If it's false, status should be false. Okay, and what this second statement is doing is just printing this value for you so you can see it, because if you don't say print, you won't be able to see. That's how Python works. Okay, so now if we want to run this cell, all we do is we click on this. Oh, I need to connect. Okay, yeah, run anyway. It's going to take some time because this is the first time I'm running it here. So you see, so here we see exactly that 2, indeed 2 is equal to 2, and our result is true. Okay, now let's look at the second one. What the second is saying, the second one is saying 2 is not equal to 2. Okay, so this is like our premise. Okay, this is like our hypothesis. So our hypothesis here is 2 is not equal to 2. Okay, now if that hypothesis is true, then we're going to get true as the answer. If it's false, then you know what will happen. So now let's run this again. Now we run this false, okay, because our hypothesis is saying 2 is not equal to 2, but we know that 2 is equal to 2, right? So this is just to get you started on on these conditions. Now let's look at this other condition. This other condition is saying 2 is less than 3. Okay, so that's the statement, okay, here, and we want to know if indeed that is true or false. And if we run this, true, because 2 is less than 3. Now if we were to change this to 5, for example, and run it, okay, don't know why. Hold on a bit, something. Maybe I think I lost connection. Okay, good. So it's it's false because 5 is not less than 3 at all. Now let's look at this other statement. This other statement is saying 2 is less than or equal to 1.99. Okay, again, that's our hypothesis here. Is that true or false? So if we run, it's false because 2 is not less than that. So you can see the whole pattern here, and it's really simple, and it's just like you making any normal statement, only that here you're using symbols basically instead of words. And let's see here, 2 greater than 1.99, that's true. 2 is greater than or equal to 2, that is still correct, we're right. This reminds me of Father Label's logic, right? Was that foundation studies? Yes. So now let's look at this interesting one here. This is saying okay, we have this letter A, okay, and we are saying A is in Amal, okay. Again, this is our hypothesis, okay, and if it's true, we'll see what will happen. This is true, okay, because A indeed is in Amal. If we were to change this to say B, okay, now you see false because B is not in Amal. Now let's say we wanted to check for AB, for example. You see, it's false, and this is very interesting because you would want to think that, oh, come on, A is in Amal. But what Python is doing here, this is for you who were in my strings class would know that this is interpreted as one entity. Okay, so this is like one string. So what Python does is it looks for AB. It's not looking for A. Okay, so if we were to add, say here, Amal, when we run this, you see that it's true. Okay, let's say we had Bamal, okay, and see what happens. No, because you see what we have is AB, but what we have in this is BA. It's it's not AB. Okay, and let's say we have this, okay, Blama. Again, it's false because there is something between B and A here. So okay, let's say this. Okay, let's see that one. Let's see. It's still false because BA. So what this thing does is that it's not like taking every character here and looking if it's in here. Okay, so if you put like BA as a string, it's definitely looking for BA as an entity. Okay, now the same thing if we were to check for Go. Okay, so Go not in today. So this is like our hypothesis. We're saying Go is not in today. Okay, again we run this, is true because go is not in today. If we were to say AY or say TO is not in today, let's see what will happen. Now it's false because TO is definitely in today. So you see, so that's how logic works really here. It's simple, just try to understand basically the syntax and you'll be fine. Okay, now there's an interesting thing. Okay, we have gone through all of these statements. Okay, and just as in logic, okay, electrical engineers will tell you they know about NOT gates. Okay, so if you have a complex logic somewhere and you add a NOT gate at the out, just at the output, then it inverts the output of that gate. Okay, it's the same thing here. So let's say this is our statement: 2 is not equal to 2. Okay, if we were looking for the opposite or the alternative hypothesis here, okay, you just add not to it. So it actually reads not, saying 2 is not equal to 2. So what Python does is that it evaluates 2 is equal to 2 and negates or inverts the outcome. Okay, so now if we were to run this, what we'll get would be 2 not equal to 2. That's false, right? Because 2 is equal to 2. So what Python did was 2 is equal to 2, true. So it just said not true, and not true is false. The same thing here. Okay, we evaluated this statement here that go not in today. Okay, now we want the opposite. Okay, so we're saying go is in today. Okay, so it's just inverting again. You see, the word go is not in the word today. That's false, right? So okay, so now let's look at compound conditional statements, because these were all just simple. Okay, if I think, sorry, let's see. Okay, that's good. Okay, so now let's see compound conditional statements. Okay, this means we want 2 conditional statements basically, not just one. Okay, so and the way we do this normally is we use maybe an or and. For example, say we want to say John is a boy and John comes from Freetown. Okay, so those are 2 statements basically, and you have just joined them using and in this case. Okay, so now let's see. Okay, so let's look at this example. Okay, so let's say we have a variable here, x equals 6.6 or something. Okay, and we want to see what this statement here gives us, that x greater than or equal to 6. So this is one statement we are making, that x here is greater than or equal to 6, right? And x less than equal to 8. Okay, and one thing you need to know about these operators or and is that, okay, for or is true when at least one of the one of the simple statements in the compound statement is true. So for example, if we were saying John is a boy and John comes from Kenema, or John comes from Kenema, that compound statement will be true if John is a boy or John comes from Kenema, or both are true. Okay, so in the and case, if any one of the statements is false, then the entire compound statement is false as well. Okay, so now let's see what happens here. So if we were to run this, we get true, okay, because basically x 6.6 is greater than 6, right? And 6.6 is less than or equal to 8. So now let's see what happens here. So let's say we want 8.4 here and see what we get. Okay, it's false, okay, because even though 8.4 is greater than 6, okay, so this is true, right? But 8.4 is not less than 8, so this is false. So the entire statement becomes false. Now let's see again. Now we want to, okay, here what we want to do is we want to find the truth value of this compound statement. Say y here, which is just a variable, is in Kabbalah, meaning is an element in Kabbalah, or is a character in Kabbalah, like the word Kabbalah, or y is an integer. Okay, so this syntax here just means integer. So whenever you say, not integer, meaning you're just finding the type of the variable. So if you want to know the type of variable, just say type. Here the variable is y, so type y is equal to okay. I need to add this one here. That was a typo. Okay, so type y is equal to int. Okay, now let's see. So y, we're saying y is k. Okay, so if we run this, it gets true because y is k. So if you look at Kabbalah, there's k in Kabbalah, so it doesn't matter what this is, this statement will be true. Okay, or let's say we want this to be 8. Okay, now there's an error here because yes, I know why. Because y is an integer, and we are saying in Kabbalah is a string. Okay, so forget about that one, that won't work there. Okay, but let's say b, for example, b is here. Okay, now if we say, for example, v, now you see that this will be false. Okay, because v definitely is not in Kabbalah. Okay, now that is fine. Okay, we move on to the next bit. Okay, and the next bit here, we are now going to if statements. Okay, we have we have run through simple conditional statements. Okay, now we want to take notch it a bit forward. Okay, now what is an if statement? Okay, an if statement is is basically just trying to check a condition or a series of condition and do something. Okay, now let's look at this example. Okay, now let's say we have a set a set of numbers a. Okay, and we want to check if a certain variable x is a member of that set. Okay, and what we are doing here is that and what we are doing here is that if x is in this set, basically we will print yes. Okay, if it's not in that set, then we don't do anything. Okay, hold on. Okay, okay, so now let's see. Okay, now this is a set here. Okay, we define the set here is that. Okay, and let's take this variable. Okay, this is just a variable. It can be anything. Okay, now let's see how to construct. Okay, how do we construct the if block? Okay, you start if block with this statement if. So whenever you write if, straight away you're starting an if block. So if, small letters, so if, then you write your statement. So you write if, then the next bit will be your statement, and this statement is what you are checking. Okay, in this case what we want to check for is if x is in A. Okay, so which is just what we have written here, x in A, and then you always have to put this column. Okay, so you put the column. If you don't put that, you get an error. Okay, so x in A, and you go to the next line. You don't need to leave this space anyway. I left this space just because I wanted to improve the readability of the code. Okay, and the only thing you need to pay attention to is that you can see that we started on this line. The if is this line. Okay, but the statement that should be executed, okay, when the if statement is true, does not need to start on the same line as the if. Okay, it should be indented, and that's something you should pay attention to. So if we were to put this here, then this will not be executed at all, even if this is true. Okay, because what Python does is that when it reaches here, it executes this line, and if it's true, then it looks for the statements inside the if block. But this is not in the if block because it's at the same level here, you see, as the if. So that's something to really note. Okay, so you need to indent it. It doesn't matter how much you indent it, it's up to you. Okay, but you need to indent it. Okay, but the other thing you need to note is if you indent the first line, say by this amount, all the following lines in that block must also start at that level. So if I wanted to put another print statement, for example, it has to start here. Then what Python will do is it will execute this, and then exit the if block. But let's see, a couple of examples here to make you understand. Okay, so now let's go. So which means this will be printed after the if block. Okay, so now let's print this one. You see, so what this is saying, these are the numbers 7842, and we are testing for 4. Okay, we want to know if 4 is in this set. Okay, so if 4 is in this set, straight away it prints yes. Okay, now let's say we were to put 5. Okay, now you can see that this statement is not printed at all, because what Python did was it checked. Okay, if x in A, okay, but x is not, 5 is not in A, so it says false. Okay, and as long as it's false, it does not execute this, it does not go, so it just moves to this point. Okay, that's fine. But now let's say we just did not want to print yes if it was true. Okay, we wanted to print no if it was false. So what do? You do the same thing, but here you add an else block here. Okay, so in this case, so you say if, so this is what will happen if it's true, and this is what will happen if it's false. So again, else, and you put your column here. Okay, and if we run this now, you see no, because 5 is not there. Okay, and if we were to put 7, you see yes. Okay, that's good. Now let's see what happens. Okay, now let's say we want to print valid if z is negative or at least 10, and invalid otherwise. Okay, now let's see. Okay, we just write z here. Okay, z can be any number. Okay, and again, you can see here that we are trying to test two conditions. Okay, we want to test if z is negative. We also want to test if it's at least 10. Okay, so what we are doing here is we are basically checking a compound condition. Okay, we check a compound condition. So now let's see. Okay, so z here less than 0 represents z is negative, because we know that anything less than 0 is negative, right? And z less than, z at least 10 means z is greater than or equal to 10. So that's why we say z less than 0 or z greater than or equal to 10. Again, put your column there and take one step inside and print valid. Okay, else, because we said otherwise, meaning if this is not true, we print invalid. And again, it's there, it's happening. Okay, so let's say we wanted to say 66, for example. Okay, this is still that. Okay, or let's say 6, invalid. Okay, because we're saying 6, so this thing checks. Okay, 6 is less than 0. No, it's not, so this is false. 6 is greater than or equal to 10. No, that's also false, so this statement here is false. Okay, 10, you can also actually, because in these examples we have only been looking at two conditions, right? If or else. Okay, but you can also construct an if block with more than two conditions. Say if it's not red, if it's not green, if it's not yellow. So you see, and now let's see. Okay, this is a little tough. Okay, so I will have to take my time a bit so that you understand. Okay, now what is the problem here? Okay, we have the path to a file. Okay, like this. Okay, this is just like a file name. Okay, but we are like we want to include where this file resides on your PC as well. Okay, in its name. Okay, so this is it here. Okay, and we want to check if this file is an Excel file. Okay, which we can see here is XLS file. Okay, or we want to check if it's a CSV file. Okay, so what basically we want to do, let me do this one after the other. So here are the conditions. Okay, if it's a CSV file, if this file is a CSV file, we want to print its CSV. Okay, if it's okay, if it's an XLS file, meaning it's ending in .xls, we want to print its MS Excel. Okay, if it's a doc file, meaning it's a Word file, DOC, it ends in .doc, we want to print its MS Word. Okay, and if it's none of the above, we want to print invalid format. And this is very important. If you're writing a small application and you ask people to pass files, but you want them to pass only specific file types, then you can use this to test if their input is valid or not. Okay, so in this case, let's say this is our sample file basically. Okay, and if a file is a CSV file, for example, it should end in .csv. Okay, if it's an XLS file, it should end in .xls in this case. If it's a doc, it should end in .doc. Okay, and you can see here that CSV, XLS, DOC, they all have 3 letters, right? Okay, and again, this is for people who were in my first string class. Okay, now what we want to check here is we want to check only the last 4 elements of this file. You don't want to check the entire file, because this is what we're interested in. Okay, the last 4 elements. Okay, and to get the last 4 elements, this is the syntax you use. Okay, so file path is a string, and this syntax just means last 4 elements. So what we're saying here is that if the last 4 element is .csv, then we print it's CSV. Okay, but if that is not so, this just means else if. Okay, here you cannot use else, because you use else only for the last part, like, you know, and when you use else, you don't need to specify any condition. What this means is that if the rest is not true, just do this. So this is like, you're just like trying to say, okay, all thing go. Okay, anything not in the if, well, not meeting the condition of the if block should be captured by this. Okay, but here we actually want to check for something else, so that's why you say it's just like saying else if, do this. Okay, so elif, that's the statement in Python. So again, now we check for .xls. Okay, if that's true, we print it's MS Excel. Then here we're testing for .doc. Okay, then finally, if none of the above is true, then we print this. So what Python does is that when you run this file, you know, it starts checking one after the other. So it checks this first. If this is correct, it prints and just exits. It does not continue. Okay, just exits this if block and executes whatever is after the if statement. Okay, so if this is not true, it executes this. If this is not true, it goes. So even if you have 100, it will do them. Okay, if this is not true, it does this finally. Okay, and now if we were to run this, now you see it's MS Excel because we have .xls here. So if we were to change it to .csv and run, you see it gives us it's CSV. Okay, now let's say we were to remove that dot and run, say invalid format, because basically Python could not find any of these, so all of these were false, so it just executed this, you know, it executed this one straight away. Okay, so let's say we had here .doc. You see, it's MS Word. Okay, now we go to nested if statements. I think this is actually the last one because it's harder than the previous. Okay, now nested if statements is just you're saying there is an if statement in an if, in another if statement. Okay, so that's what they call nested. So you do if this is equal to this, and then when you enter into like when you try to execute that statement, you encounter another if block, or maybe even series of if blocks. So let's see how that works in practice. Okay, the principles are the same, nothing changes at all. So now let's say we have this problem. Okay, and the problem we have here is let's say you are given a variable, okay, and we want to do the following. Okay, and this can be any variable so far. So let's say if the variable is a string, basically make sure it is a single alphabet, and print vowel if it is a vowel, and consonant otherwise. Okay, so which means when we are given this variable, we want to check first if this variable is an is a single alphabet, which means we want to check that this variable is a string first. Okay, and if it's a string, we want to check that it has one element only. Okay, and that this one element is an alphabet, meaning A to Z. Okay, it can be anything from A to Z. Okay, so that is one condition. Okay, then we also have another condition here, however, which means if it's not a string at all. However, if the variable is a numeric, but okay, it's numeric. Oh, sorry. Okay, if the variable is numeric but not complex, which means it's a number, like a real number but not a complex number, okay, then you print G1 if it is negative, G2 if it lies between 0 and 10, and G3 otherwise. So you can see here, this is a nested, because you have nested conditions basically. Okay, series of conditions you want to test. Okay, and just so let me pick I think there's something I would like to explain here. Complex number. Well, I know most of you here are engineers, so you know what a complex number is, but for the benefit of non-engineers here, if any, a complex number is a number that has two parts, a real part and an imaginary part. Okay, so if you say 2 plus 5j, for example, that's a complex number. So the 2 is the real part and the 5 is the imaginary part. Okay, good. Now this is the problem we have. Okay, let's see, how do we solve this problem? Simple. Okay, now let's say this is our variable. Again, it can change, it can be anything. Okay, but I am just using a complex number in this case as a variable, and this is how you write a complex number in Python, by the way. Just write complex, this is the real part and this is the imaginary part. Okay, so but that's not the point here. Okay, the variable we're testing here is var. That's the name. You can give it any name, you can even call it Chelsea. Okay, so now let's say this is our variable. Okay, but let's go back to this problem. The problem says if the variable is a string. Okay, so that is our first condition. So the first thing, because everything here happens only if this is a string, right? Because if this is not satisfied, then what you do is you go to this condition. So which means our first if block should test, okay, if this is a string. Okay, so we start with this. So if type var, and as I told you earlier, type is what you use to know the type of a variable. So if type var is equal to string, str is just what you use to specify, to refer to a string in Python. Okay, so if type var is equal to string, then this is what will happen. So no need to write this first. Okay, so initially you should start with the if. You should start with the if block. Okay, so if, let me show you this. I think this is okay. So you start. So if, okay, if type var is equal to string, so this is here, then this is what will happen. So forget about what will happen first. Okay, then, but they are now saying if that is not true, okay, what should happen? However, if the variable is numeric but not complex, okay, so which means our next condition should be, okay, we should try to check if this variable is complex or not. Okay, so the easy condition would have been, say, if the variable is a float or is an integer or is long. So there are several numeric types, like 3 types, okay, and that's too much. You don't want to. Okay, so basically there are 4 numeric types. You have integer, float, okay, you have long, and you have complex, okay. And our problem here is saying if the variable is numeric but not complex. So the only exception here is if it's not complex. So it's easier to say if the variable is not complex, then do this, okay. So your next condition becomes elif, you see, elif type var not equal to complex. So complex, okay, variable is not complex, okay. Then else, so which means if none of the above is satisfied, we just print not supported, basically. So you come here and say else, finish. So this is what you start with initially before you start, writing the other if blocks, okay. So now let's go further, okay. So we come back to the question. The question says if the variable is string, so we're in here now, so what do we do, okay, why is here, okay. So what we want to do here is write the entire code, everything that should happen, okay, if this variable is a string, okay. So now we go, make sure it is a single alphabet and print vowel if it's a vowel, and consonant or otherwise. So but let's start with this first one. Make sure it is a single alphabet, okay. So we're in here now, here basically, okay. So your first condition again becomes, is it an alphabet, okay. So, and this is what you use to, again, we did this in the last class. Var is alpha, basically is saying is the variable an alphabet, meaning, or say does a string contain alphabets only, okay. So this is what we have here. And you see, len of var is equal to 1, meaning and it has only one element, because we're basically just trying to execute that particular statement, okay. Make sure it is a single alphabet, okay. And this is what we're saying now. So we're in here, so we say if var that, okay, else. So if that is not true, what do? All we have to do is we print, you see, print not supported, okay. Again, you see, so you start with the outer first, okay. So now what do? Now we know that as long as we're in here, we basically know that this string it's a single alphabet, that we know, okay. So now we can go to the next stage, okay. Now we want to print vowel if that single alphabet is a vowel, and consonant if it is not. So basically all we have to do here now is check, see, we check if var is in the set of vowels, okay. But before we do that, you just want to convert this to lowercase, okay, because assuming someone wrote, say they wrote a here, okay, and if they wrote a here, basically you would never find a in this set unless you make these uppercase as well. So there are 2 ways to do this. You either convert this to lowercase and use lowercase here, or convert it to uppercase and use uppercase here. So this is just you trying to make your code foolproof, okay, or fail-proof, foolproof, whatever, okay. So now we're here, okay. So basically we're just executing this last part, okay, and the last part says if var is a vowel, so if the variable is in a, e, I, o, u, then you print vowel, else you print consonant. So you see, so we have finished that first part, the first. Now we go to the next one. Okay, your next statement says is a variable is numeric but not complex. Okay, and this condition just makes sure that it's not complex at all. Okay, so now what do we do? What does the statement say? So if the variable is numeric but not complex, print G1 if it is negative. Again, so our first condition here is we check if the variable is negative. Okay, and we're here. Okay, and all you have to do is, if var is less than 0, because negative numbers are less than 0. Okay, so print G1. Now they're saying if the variable lies between 0 and 10. Apparently you can do this in two ways. You can either say 0 less than equal to var and var greater than equal to var less than equal to 10, or you can actually do this omitting the and just doing it as you do in mathematics, basically, to define a range. That's one good thing about Python. Okay, so this one is just saying var lies between 0 and 10. Again, we are using or equal to because the statement says 0 and 10 inclusive. If it didn't say inclusive, then you just say 0 less than, because it's possible 0 and 10 are outside of that range. Okay, so we'll print G2. Else, this is absolutely else, because it's saying and G3 otherwise. So for all other conditions or instances, it should print G3. Okay, so this is it. Basically, this is the implementation of that small problem. Now let's run this and see what happens. Okay, so you see straight away it tells you A. You put A, it tells you A is a vowel. Okay, so you can play with it basically and see if we get the answer right. Okay, so let's say we put AC here. Okay, it tells you not supported at all, because what Python is doing is that, so it's saying, so when you pass this, it checks first. Type var equal to string. In this case it will be yes, because this is a string. Okay, then here it says var is alpha. Yes, because everything here is an alphabet. And len is equal to 1. No, because there are 2 elements here, 2 characters there, so the length is not equal to 1. So straight away it prints this out, not supported at all. So you see, so you could do several things. Okay, we could even put plus there and run. Basically not supported at all, because it's saying this is a string, okay, but this is not an alphabet. So if you were to do this step by step, Python will say var is alpha will be false. So even though it's 1 element, but no, it doesn't work. Okay, so let's put 6 basically. So you see 6 G2, because G2 is saying it lies between 0 and 10. So you could basically change stuff, okay, and see basically what happens. So G1, because -6 is negative. Okay, so and so forth. Okay, let's say we want to put complex 7x. Okay, again we run this, not supported, because it's saying from the question if the variable is numeric but not complex. Okay, so there's an exercise here for you.